Welcome everyone to a new mystery in Earth and space science. Today we're going to be discussing radioactive dating for different isotopes. So the L of today is going to be that students will be able to identify the different types of isotopes used in dating different samples and different rocks. In previous videos, we learned about how carbon-14 is used to determine the age of certain samples or rocks using carbon-14 half-life. As an initial thought, before we start this lesson, I'd like you to suggest how can scientists date a sample if the sample does not contain any carbon-14? Have a think. Let me tell you a story now. One day I was in a lab and I was given two types of rocks to date. One was an igneous rock and the other one was a sedimentary rock. I'd like you to think now, which of these rocks do you think did not contain organic material? By organic material, I mean that did not contain a once living organism. You may pause the video now to examine these two types of rocks and to be able to decide which of these rocks did not contain a once living organism. So, for the sedimentary rock on your right hand side, it's clearly shown that the rock contains different bones and fossils. You may even find wood and charcoal, and these are considered to be a once living organism. Moving on to the igneous rock, igneous rocks are formed from hot molten magma, so you will never find a once living organism. Hence, there's no carbon-14, and so we can't date them using carbon-14. Moving on to the facts we've came up with. Fact number 1. Igneous rocks does not contain a once living organism. Fact number 2. Hence, igneous rocks does not contain any carbon-14. Moving on to the last fact, fact number 3. We have to find an alternative for carbon-14 to be able to date igneous rocks. In dating igneous rocks, one of the most common isotopes used in radiometric dating is uranium-235 or U-235. So uranium-235 is used to determine the absolute age of igneous rocks. We find uranium-235 inside the igneous rocks. So what happens to uranium-235 inside the igneous rocks? So uranium-235 decays into lead-207. Uranium-235 breaks down into lead-207. Just a reminder, lead is the name of the element. So uranium-235 is the parent isotope, while lead-207 is the daughter isotope. As you all know by now, to be able to date a sample or a rock, we need to know the isotope and we need to know its half-life. So by now we know that we're going to be using uranium-235 to date igneous rocks. So now what is the half-life of uranium-235? The half-life of it is 704 million years. That's a very, very big number. So this big half-life of uranium-235 is going to be very, very helpful in dating very old rocks or samples because the half-life of it is very huge. Let's extend ourselves a little bit further and talk about an extra useful radioactive isotope, which is potassium 40 or K40. This specific isotope has a very long half-life, which helped in determining the age of the Earth. It has a half-life of 1.25 billion years. You might be wondering now about the age of the Earth and how old is the Earth. So radiometric dating suggests that the age of the Earth is around 4.54 billion years old. So it's the end of our lesson and let's rock the test. Question 1. Which of below isotopes cannot be used to determine the absolute age of an igneous rock? I'm emphasizing on igneous rock because it means that there's no once living organism. So which one of these isotopes do we use for an igneous rock? Is it uranium-235, K40, which is potassium 40, or carbon 14? Have a think and you may pause the video. So the answer for this question is carbon 14. We use carbon 14 to determine igneous rock's age. Now moving on to question 2. Uranium-235 is very helpful in dating very old rocks and samples. Why is it very helpful? So option A, it has a very small half-life. We know that it does not have a very small half-life. It has a half-life of 704. Option B, it has a very long half-life of 704. And option C, it has a very long half-life of 1.25. 1.25 is for potassium, so that's also the wrong answer. So the right answer for this question is going to be B. It has a very long half-life of 704. Right, I hope this video helped and thanks for watching. Bye.